Welcome back to the deep dive. Today we're doing something a little different and looking at a single set of product specifications.
That's right. It's for the DVIGear DVI-2530 AOC HDMI active optical cable.
Part of their new Hyperlite series. And our mission, really, is to see how the technical design here lets these cables solve some, really persistent problems in professional AV.
Yeah, problems like distance and just pure durability.
So where do we start?
I think we have to start with the foundation. These are hybrid cables,
Hybrid, okay.
meaning they combine 4 polyfluorinated optical fibers, POF for short, with 6 standard copper wires.
And the POF does the heavy lifting for the video signal.
Exactly. And what's important here is that POF isn't glass fiber. It's a plastic, which is key to its flexibility and lets them push these signals up to 100 meters.
100 meters, that's about 328 feet, which is just a huge run for HDMI.
It's massive.
So what kind of performance are we talking about over that distance? The spec sheet says an 18 gigabit per second data rate.
Yeah, that's total. It breaks down to 6.0 gigabits per lane.
And that speed is what gets you up to 4K resolution at 60 frames per second. It also mentions 8-bit 4.4.4 color or 10-bit 4.2.2. Why do those color specs matter so much?
Well, it all comes down to fidelity. When you see 4.4.4, you should think uncompressed, full color information.
So no artifacts.
And that's essential for things like broadcast or medical imaging where you just can't have any compression.
Right.
And that connects to the whole idea of mission critical use. The optical transmission itself is the key because fiber is completely immune to environmental noise.
So RFI, EMI, that kind of thing.
All of it. It has a very low profile, which is great for security, too.
That's a huge benefit, making sure there's no electromagnetic leakage for eavesdropping.
Yeah.
But that brings up a question for me. If the fiber is so secure, why are those 6 copper wires still in there? Aren't they a vulnerability?
That's a great question, but no, not at all. You absolutely need them.
For what?
They carry all the low-speed control data, things like HDMI CEC for controlling devices, and the HDCP copy protection handshake.
And they can't run over the fiber.
It can't. It needs that electrical connection. But the data is so low speed, it poses basically zero security or noise risk to the video signal.
Okay, so the signal is protected. But for installers, the physical environment is often the biggest fight. How did DVIGear design these to, survive being pulled through a wall?
This is where the engineering really gets interesting. They're compact and light, sure, but the critical part is that they're plenum rated.
UL CMPOF certified.
Yes, which means you can legally and safely run them through air handling spaces in a building. That's mandatory in a lot of places.
And the flexibility specs are, almost unbelievable. It says a minimum bend radius of just 2 millimeters.
It's incredible, isn't it? That's tighter than you can bend most phone chargers.
How does a fiber cable handling 18 gigs not just snap?
It's that POF material again. That plastic fiber allows for incredibly tight turns where glass would just break.
That makes sense.
And to make the pull even easier, the HDMI connectors themselves are removable.
Well, that's smart.
Yeah, you detach them and what's left is a tiny cross-section, just about 12 by 10 millimeters. Makes it super easy to pull through narrow conduits. Then you just reattach it and there's a locking pin to keep it secure.
What about power? Does all this tech need an external power brick?
Nope. It's designed to just draw what it needs, which is less than 1/4 of a watt directly from the HDMI source device. No extra headaches for the installer.
So let's sum it up for you. You're getting long-distance 4K at 60 frames per second, total immunity to noise for secure setups, and it's incredibly easy to install.
Right, the plenum rating, that 2 millimeter bend radius, the detachable connectors, it's a whole package.
It really is.
And that actually leads to a final thought for you to chew on. These specs show a real shift in how we think about infrastructure resilience. We know the cable has a tensile load over 200 newtons and can resist a crush force of over 500 newtons.
So they're built tough.
Extremely tough. So if that's the case, what new challenging environments think about high vibration areas, complex industrial settings places that were impossible for high-res video before are now actually open for professional AV systems?